Okay, last time we talked about SSL and TLS. Let's take a look at a simplified protocol. So we have an SSL client here trying to connect to the server. So basically, the SSL protocol define a lot of message exchange handshake protocols so that they can communicate and authenticate each other. So first, the client simply connects to the server, simply says hi and request authentication, and then the server prove its identity. So by sending a certificate, so that certificate must be signed from some other company so that the client trusts. And also there's optional message, okay, request the client to authenticate himself, okay, and also negotiate something so they can agree on a set of protocols, something like that. That's a simplified version, and there are a lot of details, and basically the idea is very straightforward. Basically the client says hi, and then I attach my the name of the cipher that I can support, okay, and then what credentials I have, and the server replies the certificate, okay, and then choose the cipher chosen by the server, okay. In the second message, the server selects a secret key, okay, so the computer key that depends on our client and our server, so the ID of the client and server, and some secret information. So that's basically setting up, okay, the key exchange, okay. So then they can exchange keys. That's SSL, okay. The phase one is the handshake. So Bob establishes a TCP connection to Alice. So Alice here, Bob does the handshake, okay, and then authenticates Alice via a signed certificate. So that is why SSL provides security. So the identity the users they can trust, okay, and then creates, encrypts, okay, that's public key, sends master secret key to Alice. So the back and forth, that's the phase one handshake, okay. So we can see that here Bob creates a master secret key MS and then uses to send to Alice, okay, and then Alice can decrypt, okay, using the KA plus, or using Alice's secret key. Once Bob has already been sure about Alice's identity, Bob can create a master key and encrypt that master key with Alice's public key. Okay, so here the public key cryptography provides an important role both in the authentication using signature and also key management. Okay. Phase two, key derivation. So they use shared secret to generate 4 keys, data encryption key, okay, data encryption keys, and also a MAC key, okay. So that's for confidentiality and authentication integrity. So that's SSL phase 2, key derivation. So after they're all done, phase 3 is data transfer. So then they'll transfer data. So the data can be encrypted or not. So depending on the agreement of both parties, whether you want to have your data encrypted or not, what type of cipher you want to use, so on and so forth. That's data transfer phase 3. Okay, TCP byte. So once an SSL connection is established, then there's a session, an SSL session. So it's a transport, uh, just like a transport protocol, but it provides security services. Okay, and it's peer-to-peer relationship. You don't have to worry about anything, anybody in the middle, anybody on the path from the client and the server. Okay, and this connection is short-lived as well, just like TCP connections per web page. Okay, so TCP connections is established per web page. When you close the web page, then there will be the connection will be over. Okay, and if you open several web pages at the same time, there will be many TCP connections. Okay, they're all associated with the session. An SSL session is created by a handshake protocol, so that some cryptographic parameters are agreed upon, and these parameters are used for each connection within the session. So that's basic idea. And it associate so a client and a server, they're associated. The server will store session ID, and also master secret will be created, and the client presents a session ID how that server remembers, so that they can skip. So this is SSL. So replay attack won't work, because you have a session ID, and then you're in the middle of a certain round. If you replay earlier packets, and they will have an earlier nonce. The attacker has no way to know what the nonce is. So basically, this is SSL. Okay, this is the transport layer. So this is something that the network layer does not have. For example, like IPsec, there's nothing like this. Okay, so the IPsec, all these security services, they belong to the network layer. So only we're only sure that a packet is sent from an address, authorized IP address, to another IP address. That's everything we know. We don't have a set of protocols, like we set up a set of security parameters, and then we transmit packet, something like that. And then if we're in the middle of the connection, at each step, what should we do? And then if the other party fails to reply, what should we do? Things like that. They're not these questions, these problems are not addressed at the network layer. So it's beyond the scope of network layer. That's one of the major differences between these things. SSL architecture. Basically, SSL implements the initial steps, okay, using the handshake protocol, so which establishes security capabilities and authenticate the server using a certificate. So in this phase, no real data has been transmitted. It's just a handshake session, okay. And SSL specifies other protocols as well, okay. Record protocol and cipher spec protocol, okay. Also alert protocol. These details you guys can check. The standard HTTP uses port 80, okay, but SSL uses port 443 by default. So they use different ports. Okay, that's different. So, for example, like in a lot of local area networks, like our EE department, we block everything that is not secure. We block all, for example, HTTP connection, ordinary HTTP using port 80 from other, from outside, or uh, anything like telnet, okay, they don't use. There's no security at all. So if you guys know telnet, maybe I guess maybe you guys are too young. Have you guys heard about PTT? Right, that's one of the specialty of Taiwan, one of the Taiwanese specialties, because there's still a lot of older people. I'm by older people, I mean like myself. We're still using PTT. Actually, PTT was created by one of my classmates. Okay, my class, the uh, the founder of PTT is called Du Yijin because he has a nickname, Pa Tai Tai PTT. And then I still remember that, when I was a freshman, when I was in at NTU, and then he asked me, "Hey, I just I'm organizing a website, a large website. I would like to join." He asked me, and at that moment I thought, why don't we just go back and study, right? Why don't we waste this much time? Later, I didn't know that PTT was that successful. Anyway, it was really successful. It's almost as successful as one of our major news agencies. In Taiwan, the a lot of reporters they just take they just take the contents from PTT or D card these days, or 苹果日报, 水果日报, something like that. I mean, they're not like older reporters. They really get up early, like 4 a.m. in the morning to get the exclusive news from you know somewhere, something like that. They're not like that because people change and things change. So this PTT website, we use Telnet. That is a really old network protocol. And both Telnet and FTP, those are the protocols I used when I was a freshman uh, at NTU. So that was really old, and I didn't know that those protocols are they're not security. They're not secure at all. For example, for the Telnet, let's say if you have an account at PTT, your username and password they will be sent to the server using plain text. Incredible, right? So your password sent as a plain text. So anybody in the middle, anyone is on the path between your computer and the PTT server can get your password. That is why it's extremely insecure. I mean, I should say there's no security at all. Now PTT blocks the alternate, so they have to use other protocols like SSH, okay, or secure remote login. Those protocols they are developed on top of SSL. Okay, so we have secure FTP, secure telnet. They're not called telnet. We sometimes call SCP. Okay, you can either use SCP, okay, or other protocols to view websites. HTTP, right? Those they're run at different port numbers. But if it's built on top of SSL, well, they use a different port number. Okay, so we have those protocols like HTTPS, okay, and SCP for telnet, or SFTP. Those protocols. SSL record protocol. So SSL provides basic security services to various higher layer protocols. So you can use build HTTP on top of that, which is HTTPS. Okay, and it record types of the record type specifies what is being carried by the record protocol, and also fragments and reassembles application data. Okay, provides both two services, confidentiality and message authentication for each SSL connection. The confidentiality uses the shared secret encryption key for encryption. Message authentication using the shared secret integrity key to create the MAC. They use different keys, just like what we've seen earlier. So the record protocol operation looks like this. Let's take a look at the diagram. So the application data is like that. They fragment the application data into pieces, packets, and then you have the option to compress or not, and then you add MAC at the end. So then those messages they will be confirmed, and also and then you encrypt. Okay, yeah, you encrypt and then this whole thing is they append the SSL record header. Okay, in front of that. That's record protocol. There's change cipher spec protocol. That's the simplest SSL protocol. It has a single byte with a value 1, change cipher spec. Okay, so it completes the handshake protocol. It sets the security parameters. Okay, it basically says, okay, from this point, all records that are received will be protected. Something like that. This changes cipher spec. And also has alert protocol. Alert has some fatal warning, something like that. Okay. It's used to show that there are errors, so a session must be terminated. Handshake protocol is complex, the most complex of the SSL protocol. Okay, the record type is 22. Okay, so that's a handshake. There will be a lot of messages coming back and forth, as we have seen earlier. Okay. In phase 1, yeah, there are a lot of details. Not cover everything, because you guys can, for those who are interested, you guys can take a look. Phase 1, phase 2, okay, and in the phase 2, the key exchange, they basically check the certificates. Okay, and then this certificate is called X.509. This is a format of certificate. It's the most commonly used. So it tells you what type of data should be put where. Okay, so which part is the certificate, which byte is what. That's X.509. That's a certificate of a particular format. Okay. And the key exchanges use Diffie-Hellman or RSA. The signature, there could be signature only key. Okay, so that's the handshake protocol phase 2. Phase 3, client authentication and key exchange. So the client checks the server certificate and validates. Okay, see whether or not it's authenticate user. Okay, and the client sends pre-master secret encrypted with the public key of the server. So then they will have the shared key. Okay, so if RSA is used, then basically the client chooses a master secret. Okay, and then encrypts that secret with the server's public key. Okay, or alternatively, they can use Diffie-Hellman key exchange. So if Diffie-Hellman is used, then they'll follow Diffie-Hellman protocol, and then the client and the server, they will end up with a shared secret. Okay, so that's handshake protocol. Handshake protocol phase 4, will be finished. Okay, so client server, they know that the handshake is complete. Okay, this client sends this message, change cipher spec, to tell the server that it's complete. Okay, and then sends a finished message. Okay, the server repeats. Okay, and then verifies key exchange and the authentication process. Okay. So those are some remarks. The handshake protocol usually creates an SSL session. Okay, SSL session. Each session may have multiple connections. For example, you may have a lot of connections. You may open many websites at the same time. Okay, and those sessions they will avoid unnecessary and expensive negotiation of security parameters, i.e., the um, asymmetric crypto protocols, RSA, Diffie-Hellman. Those are expensive ones. Okay, so symmetric ones are cheaper. Each session has a pending state and the current operating state. Okay, so that's handshake. Now, let's move on to TLS, the transport layer security. The TLS is almost like almost SSL. So the SSL was originally designed by Netscape. I mentioned that last time. It was the first successful company that had a really good software product of a browser. So that's kind of like the forefather of web browsers. So that they existed even before the Internet Explorer. So Internet Explorer was a bad browser, i.e., Netscape was good. So Netscape basically designed SSL version 1 in the 80s or something. And then over these years, they are improved. So in the 90s, they are version 3. So SSL version 3 is probably the latest version of SSL. And then after that, it's sold to another company. Okay, so it's kind of like a company bought another company. So then it's specified in this RFC 2246. If you guys know what RFC means, okay, it's kind of like an internet draft. If there's anything usually developed by IEEE or many other organizations, if they want to establish protocols, they usually put their drafts online, and then they use this name called request for comments, RFC, and then they give a number. So these documents they all have kind of like an ID number associated with it. So RFC 2246, you guys can just Google RFC 2246, then you can find the original document. Yeah, so RFC 2246, for example, RFC 2246. Yeah, maybe I can use this one. Okay, if you guys Google that, then you guys can check. Okay, these are the original documents. Okay, it's this organization IETF was the one that set up standards. Okay, so these are the original documents of RFC something. All those networking protocols, their original documents was like that. So you guys can, we are living in this era. In this era, so everything can be found online. So you can just Google this, and then you guys can take a look at the original document, and then you will have a better idea of what it originally looked like. So the TLS 1.0 is essentially SSL version 3. There's some minor difference. We can basically regard TLS as an improved version, enhanced version of SSL, but the TLS version 1.0 is almost, I would say 99% the same as SSL version 3, almost the same. Okay. Anyway, TSL messages are used with EAP or WLAN authentication and key exchange. Okay, that's actually the same for SSL. Okay, WTLS is a variant of TLS. Okay, it's used in wireless application protocols. Okay, so the difference, I said that SSL version 3 is almost identical to TLS 1.0, except for the following 3 points. Those are minor stuff. Number one, TLS can extend by adding new authentication methods. So you can use a little more authentication methods than SSL version 3. Number two, they use session caching, so to improve the performance. Those are just some minor detail. And also, TLS separates the handshaking process from the record protocol, but SSL does not do that. So it's pretty much like that. Okay. So that's done for lecture 12. Let's move on to lecture 13. So we'll be looking at other security topics. Wireless. Now we're focusing on wireless security, wireless network security. So we'll be talking about 802.1x, EAP and radius. And before that, we have I would say probably the first wireless security protocol is the WEP protocol. It's called Wired Equivalent Privacy. That's one of the protocols that you get online. It was the only standard for wireless LAN security until 2000. Actually, before the year 2000, nobody really cared about security because at that moment, internet, everybody is interested in building up new things on the internet, like multimedia and stuff. I remember when I was a student in graduate school, I was studying. My graduate studies started from the year 2000 to 2004. Okay, so at that moment, when I was applying to graduate schools in the U.S., a lot of people, they're interested in multimedia topics like that because they build on top of the internet. So that's the hottest topic. So at that moment, nobody really cared about security. Let's say if we want to get online, on campus, for example, and you have Wi-Fi. In that case, most likely you'll be using WEP. That's the only standard, but it was really poorly designed it's so poorly designed in an extent that it's almost a negative. It's almost a perfect negative example, like how poorly you can design a protocol. So that's WEP. The objectives, they want to have reasonable strength, but it turned out to be a total disaster. Okay, it's self-synchronizing, efficient, exportable, and optional. Those objectives, they're actually proposed by networking people. They have no idea what security is about. Anyway, we'll be we'll be looking at WEP first and then analyze that. So let's take a look at the characteristics. The keys are either 40 or 104 bits. Okay, 100 bits long. Okay, and they're symmetric. Okay, and then the keys are static. They never change. Okay, never change the key unless you manually configure it. And there are two types: the default and the key mapping keys. Okay, so the default key is this. Okay, all the default key. Okay, and also their key mapping key. Okay, so the default key is in use is called the active key. Okay, something like that. Key mapping keys, it's not widely deployed. Okay, each mobile station, okay, portable device, mobile station has a unique key. And the AP, the access point, keeps a table of MS. Okay, something like that. So no big deal. Okay, let's take a look at the authentication. So this is your mobile station, your laptop, and then you're trying to access network through the access point. So you send an authentication request to AP, and then the AP will reply the authentication response. Okay. The shared key authentication. So basically, it uses a version of the challenge response protocol. Okay. There's no key exchange. Okay. And no key exchange. So that is why it's easy to hijack sessions. Okay. And so the open security authentication is like this. Shared key authentication is like that. You send a request, and then the AP will give you a challenge, and then you response. Okay, and then authentication success. So this is only one way. Okay, open security authentication. Okay, so this is two-way authentication. So this is one way. That means the access point does not ask the mobile station to authenticate itself. So a hijacker can be any hijacker can be can be a mobile station and just try to get to credentials. So you basically the idea is based on shared key. So it allows the AP to know that the MS possesses the right shared key. So I have to have shared key set up before that. And the process is the host requests authentication from the access point. Access point sends a nonce. Okay, the host encrypts the nonce using the shared key, using RC4. So this is the keyword. RC4 is used. If you guys know RC4, what is RC4? We learned RC4 a long time ago. It is a stream cipher, right? So what is stream cipher? It's mostly used in, for example, like streaming video, that kind of thing. You basically those these stream ciphers. They take the shared key to create pseudo-random numbers, right? And then those pseudo-random numbers are just to be are just to be XORed with the actual data. Okay, so if you want to use this type of protocol, there's only one thing you have to be very careful, very careful about. Do not use the same key twice, right? So I mentioned that many times. Well, this is the only thing that you need to know in order to use RC4. But can you believe that the designer of WEP actually used the key twice? They actually allow the key to be used twice. Can you believe that? So this is like a total disaster because such an important protocol was designed by an outsider. They have no idea about security at all. Okay? So it's not that RC4 is a bad algorithm. No, it's not like that. Actually, RC4 is good, but they allow the key to be used twice. Okay, so the AP decrypts nonce and authenticated host. Okay, the authentication is not mutual. So as we saw earlier, there are scenarios that you only use one-way authentication instead of two-way authentication. The confidentiality is basically so the data packets are encrypted using RC4. Okay, so you should not use the same key twice, right? Okay, so each packet in 802.11 is encrypted separately. Okay? There's only one key shared, one shared key between MS and AP. So that's a disaster because there's only one shared key. So if you actually you terminate this session and then you try to initiate another session, you're still using the same key. So then it will be easier for the attackers to crack your key. Okay. So this idea in web is that okay, so combine the shared key with the IV 24-bit initialization vector. That will be changed. That changes for every packet. But this thing is this 24-bit initialization vector is just way too short. Okay. So it's another mistake. So you allow the shared key to be used twice and you use RC4, and then your IV was not your IV was too short. Lots of problems. You guys can take a look at those problems. Okay. So that is really serious. Okay. So there are a lot of attacks against WEP, and then it's easy, very easy to be cracked. Okay. So anyway, let's sum up the weakness of WEP. Initial vector is too short. Okay. And then you can even reuse it. That's a mistake. Okay. And the per packet key is constructed from IV. So that's another mistake because it depends on IV. So if an IV is too short. Okay. And then there are many other many other problems as well. Okay. Master key is used directly and no update. So anyway, the design of WEP is a total disaster. It's miserable. Okay. So we cannot use it. Okay. So that is why we're going to talk about 802.1x. Okay. So before that, let's talk a little bit about a different Wi-Fi and 802.11 because a lot of people they actually they're confused. So just in case you guys are confused with these two ideas, so the Wi-Fi, everybody knows Wi-Fi, but what is that? Okay, so Wi-Fi is actually a commercial alliance. Okay, it's this word is made up. Okay, because those companies they want to create a buzzword so that everybody can remember, so that it will be easy to remember, and then it's better. It's will be more effective to promote this idea, promote their product. Anyway, the Wi-Fi refers to the wireless local area network, and 802.11 is an IEEE standard. Okay, it specifies the physical characteristics of the 802.11 local area network, not necessarily wireless. So the local area network is mainly wired. It's wired network. And 802.11 they have many sub protocols. Okay, they cover the wireless part. For example, in the beginning we have 802.11b and then we have A. What's weird is that actually 802.11b was released before 802.11a, and then we have like GH and then I is for security. Okay, and then now we have like AB, AG, that kind of thing. Anyway, if you compare for example, the original 802.11b, A, that kind of stuff, that's almost like Wi-Fi, almost. The 99% are the same. But these standards, they are designed by IEEE. So IEEE is a non-profit organization, and then in that organization, people, most people there from there, for example, I was participating in IEEE conferences as well. Sometimes they have task groups. They want to design protocols. They will release documents, RFC something. So anyway, they're divided into many groups, and then it's an open society. Everybody can contribute. But the thing is, if you want to contribute, you have to join their conferences, okay, join their groups and contribute. And because it's an open society, everybody can contribute, including the companies. So those companies, they have their technology, okay, from within their company, and then sometimes, I should say oftentimes, that they like to promote their technologies. So all those bigger companies, like Huawei, for example, they have a lot of people join IEEE conferences to promote their technologies. So it's not that the IEEE people, they're independent of the companies. They discuss about the ideas. They After they finish their ideas on something, they release their document, and then you take a look at those document, and then the specs. Okay, and then you can make your product. It's not this way. It doesn't work this way. Okay, every major company hire somebody, so then they actually contribute to those IEEE conferences, and then those companies, they want to promote their own technology, so that when a protocol is finalized, their product is ready. Okay, so before those protocols were finalized, they already have their products ready. So then, before IEEE 802.11b, which is the first standard for wireless network, there's a Wi-Fi alliance which does not belong to IEEE, but those people, there are a lot of overlapping. Those people within those companies, there a lot of them, they're part of IEEE task groups. Okay, so those group of major manufacturers, they have their own standard, which is more than IEEE 802.11b, for example. So then they have their own way to solve interoperability problems. Okay, so they're faster because those company people, the people from industry, they work faster than IEEE, than non-profit organizations like IEEE. Okay, so anyway, they're almost the same. So we can say that Wi-Fi has different versions, starting from 802.11b. There are many different versions. Now we have AG, AH, things like that. They're almost the same. Okay, so anyway, but this is commercial stuff. The 802.11i specify a lot of security stuff. Okay, that the for example, it defines a new type of network called robust security network, RSN. Okay, and then this is not compatible with Wi-Fi equipment, so this is stricter. It has stricter standards. So this 802.11i task group develops security solutions based on the current capabilities of Wi-Fi product. That's called TKIP. So we have a lot of protocols. We have like a plethora of those protocols. Okay, so the Wi-Fi protected access, WPA, is a subset of this RSN. If you guys have set up your wireless network, maybe you guys will. I'm sure you guys will heard about this WPA, because WPA actually is a much better version of WEP, because WEP was a disaster. WP sucks, right? It's basically nothing, not effective. Okay, but WPA is one of the major protocol that's used actually on campus. Okay, so it's more complex and scalable and much more secure compared to WEP. So the TKIP and the lower layer we have TKIP and CCMP that's specified in 802.11i. Okay, so it's by the designed by 802.11i working group. This group consists of mostly security people. Okay, they're people that are really dedicated to security. Okay, because this group was formed later, much later than the earlier groups, uh, earlier working groups. So this one was formed something like in the year of like in the 2000s, something like that. So it has counter mode with CBC MAC protocol. We already talked about CBC MAC. Okay, so provides enhanced data integrity over WEP. Okay, the upper layer is 802.1x. This is a standard for port-based access control developed by a different group, a different body of the IEEE 802 organization. So IEEE is extremely big. It has a lot of organizations. It's not just dedicated to networking. There are a lot of other stuff as well. And then within the IEEE networking group, there are a lot of other organizations as well. Okay, so 802.1x is one of our major topics. Oh, by the way, I just found a mistake here, so I should correct it right away. So this is 802.x 1x. This x should be capitalized instead of lowercase. This should be in uppercase. If you guys remember, if you guys know, so this should be in uppercase. The 802.11a, 11b, those are in lowercase. 802.11i, those are in lowercase, but 802.1x, this is in uppercase. So 802.1x provides a framework for a lot of authentication, encryption, key distribution, all these security credentials, security protocols. The 802.11 does not have those things. It's designed completely by networking people. So access control. So that is our major topic. Okay, so we have to know that who are the bad guys, who are the good guys. So let the good guys use our resource, and then we stop the bad guys from using our resource. Okay. So basically, related to WPA and RSN, they use 802.1x and EAP and radius, which is one of the important topics we'll use. And then we'll talk about EAP a lot because we actually use EAP at NTHU on campus. If you guys try to connect the wireless network on campus, there's an option called NTHU PEAP, right? That PEAP is actually EAP. It's protected EAP. It's kind of like enhanced version of EAP. So that's a thing we're using every day. Okay, and then if you guys do manual network setup, you may see those options: radius, EAP, and that kind of radius, TKIP, that kind of stuff. We'll talk about that later. So that's enough for today. Let's stop.